For question 6b, we have one more layer added on to the problem that we had in 6a. So here we had repetitions, but here our repetitions are going to have a period that is not 2 pi. So looking at my period, so the period is going to have a horizontal compression. There's this horizontal compression here of 3. So that means that my period is going to be 2 pi over 3. And that's important. And I'm going to make sure I've written that down because I'm going to need to use that when I do my repetitions for my solutions. So this is, again, a quadratic, so I need to factor this. I'm going to factor out the common factor of tan. And what I'm left with then is root 3 tan x plus 1. And again, since it's equal to 0, I can solve these two pieces independently. So tan 3x equals 0 means that the 3x angle is going to be at 0. Well, I better write this, skip the step here. Let's start with the tan x equal to 0. The tan 3x is equal to 0. So in my picture, that's going to happen here and here. So my angle, theta 1, is going to be at 0. My other angle, which I'm going to call theta 2, is going to be at pi. Now I need to actually solve for the angle x, so divide both sides by 3. I still get 0 here. When I divide both sides by 3, I get pi over 3. Now I have my two solutions. These are primary solutions, but they have repetitions. And since this is all real values, I need to show the repetitions by adding on plus n 2 pi over 3. In the previous problem, we added n 2 pi because the period was 2 pi. Here, the period, because of the horizontal compression, we're going to use a period of 2 pi over 3. And so we have two solutions within the 2 pi. I found both solutions, and then I'm going to show the repetitions with an n 2 pi over 3. So there is two of my answers, and I'm just going to maybe highlight this. There's one solution here. Oops. There's one solution here and one solution here. Okay, so then I need to solve for the other bracket here. So I have solutions here as well. So this ends up being tan, this should have been 3x in there, is equal to negative 1 over root 3. Just going to fix that. This should have been in here, a tan of 3x. And that's what we're solving for right now. So in our picture then, negative 1 over root 3, slope of negative 1 over root 3. And I'm going to go root 3 and 1 down. Okay, I just need to change colors here. So I'm going to go 1 down and root 3 across, gives me this slope triangle. So I'm going to be in that position. Okay, so that's going to be root 3, negative 1. That's my 30 degree position in there. And I know that it's going to also occur on the other side of the circle because I have the same slope on the other side of the circle. It's a negative 1 over root 3 slope. So then I'm going to write this first angle as x. I'm going to call this, actually, since it's my third angle, I'm going to call this x3. And that angle is going to be, and I'm going to use the quadrant 4 angle, and that's going to be negative pi over 6. Solving for the actual x, I'm going to get negative pi over 18. Now this could have been also 11 pi over 6, which would make this 11 pi over 18. So these are the same primary solutions. Okay, now it doesn't matter which one we use as long as we are in that position when we solved it. So I end up with 3x. The other solution is going to be in quadrant 2, and that's going to be 5 pi over 6. So when I solve for x, I end up with 5 pi over 18, and those are my two primary solutions. Okay, so then I want to, because since it's all real values, I need to use my repetitions. My repetitions are going to be plus n, and I'm going to use a period for my repetitions. So plus n 2 pi over 3. And those represent the 4 primary solutions, and the n 2 pi over 3 represents all the repetitions, because this solution repeats itself every 2 pi over 3 because of the horizontal compression of 3.